Hello everyone, in this video I'm going to teach you how to assemble the bevel pinion and gear that we modeled in the previous video. Okay, to do that we need to have separate files for pinion and gear, while now we have two of them just in one file. To do that, I just first in our original file I suppressed the revolve to feature which was used to make the gear. Now if I suppress it, I will have the pinion alone, so now I use the save as function to save it as pinion. Okay, now I unsuppress the revolve tool and also unsuppress all the other features that were suppressed because I suppressed the revolve 2. And now I suppressed revolve 1, which was used to make the pinion. Okay, now by doing that we have only the gear, and I save as this file also as gear. Okay, I closed the files. Now I need to make an assembly file, so I click on the new and select assembly, click OK, and I select both gear and pinion by holding the control key, and I open pinion and gear to insert them in the assembly file. Okay. As you know, the first file that you insert in an assembly environment is just fixed and you can move or rotate it. But we need to make some mates. So I just right click on that gear and then select float so that it can be easily moved or rotate in the assembly space. Okay, the first mate I use is the basic vertex of the cones that was used to make the pinion and gear. I want to make them coincident, so I click on one point, then I click on mate, and then on the other point, and OK. I OK it. It's just the first mate. Okay. I can also make a coincident mate between this point and the origin of my assembly. So I click on this point again. I use the mate command and I select the origin from the design tree here. And it's the second mate that defines my assembly. Okay, now I rotate a little this pinion so that I can choose the vertical axis of the gear, and I want to make a mate between this axis and my front plane. So I click on the front plane, I select mate, and then I click on the vertical axis of the gear and I OK. Okay, now as you can see, the gear can rotate and we don't want this movement, so I make a parallel uh, mate between my top plane and the bottom face of the gear like this. This is a parallel mate because they can't be coincident. So I click on OK. Now, as you can see, my gear can just rotate and does not have any other movement. Okay, now what should we do with the pinion? We need some also mates for the pinion so that it will be on the right position on the gear. To do that, I need two mates for that. As you can see, it should rotate like this. In fact, it should rotate like this on the uh, gear. So I need two mates. One is that the angle between the two axes is 90 degrees, but be careful to choose the right axis. The one is this, and so I click on the main axis of the pinion. As you can see, when I click on the pinion, click on this line, the pinion here gets highlighted, which means that this line belongs to pinion. And then I select mate from here, and I select this line which belongs to gear. As you can see, the gear highlights, but I want this to be perpendicular as we know, and then I click OK. Well, now we are almost done, but we need yet another mate. Which mate? The mate that confines the horizontal axis of the pinion with the front plane. Okay, so I select this line, and to be sure that is for the pinion, as you can see, the pinion highlights here. So I select this line, I click on mate, and I select the front plane so that this axis always is in the front plane, and then I click on the OK. Well, now my assembly is done, and as you can see, I can rotate pinion and gear, and they are perfectly matched. Okay, now we don't need these sketches anymore, and we can hide them so that we can see a better view of the assembly. To do that, I click on the view on the hide show, and I hide all the sketches. By default, it's enabled. It means that the sketches are shown, but if I click on it, all the sketches are hidden. Okay, we are almost done, but as you can see, there is no relation between the pinion and gear, and we should use a gear mate so that they rotate with each other. Okay, you can see that they are almost perfectly mated, and they are interacted very good, but there are, as you can see, some interferences in here. To remove this problem, we should play with the profile of pinion and gear so that they will match perfectly in the space between them, and you can do it but yourself. But what I want to do now is to make a gear mate so that they rotate based on the speed ratio of 2 to 1. To do that, let me just open this file and make a hole on a pinion and gear. I click on the pinion, I open this file, I open a sketch on this plane, and I draw a circle with the center at the origin. The diameter of this circle, for example, I select to be 15. Then I click on the feature, extrude cut, and I can select up to surface and select this surface as the end of my cut, and I save it. One thing I need more is to make an axis for this center of the hole. So I select axis from reference geometry, and I select this cylindrical surface, and I okay, it's good for the pinion. I do the same for the gear. I open the file, I click on this plane, open a new sketch on it, make the view normal to this plane. I select circle, draw a circle, and I choose this one to be, for example, 20. Click on the feature bar and extrude cut, and like before, it's by default the previous settings which was up to surface, and now I select this plane at the end of the hole, and I okay, and I also select an axis for the gear. Well, I save this and now I return to the assembly file. To see the axes that I defined for pinion and gear, again I use the view control. I click on the view, hide show, and click on the axes so that I can see the two axes that I defined for pinion and gear. I need these axes to model and define the mate, gear mate for the pinion and gear. Okay, I click on the mate, and from the four tabs that we have here, I select mechanical and I select the gear mate. Here in this box, I select the pinion and the gear axes, and the gear ratio, as we saw, was 1 to 2, but it's good practice to write here the number of T's for pinion and the number of T's for gear, which were 20 and 40. Okay, I click on the OK, and now it's done. Now you can see that when I rotate my pinion, the gear also rotates perfectly, and as you can see, they almost perfectly match. But in order to remove this small error, we can work on the pinion and gear involute sketches so that they will perfectly match with each other. But for the purpose of practice and for the purpose of this training, I think it's almost good for now. Thank you for watching this video.